let's get started again. Sorry about that. Okay, so physical property is something, guys, that you can measure or observe or notice without changing the substance. And when I mean changing the substance, I mean I'm observing a piece of steel, and if I observe it, it turns into something else. Okay, that would be it changing. I don't mean like it changing shape. I don't mean it changing temperature. Okay, I don't mean that. Okay, I mean without it changing what it is fundamentally. Okay, without the atoms changing. Okay, so some examples of physical property would be color, size, temperature is a physical property, boiling point, melting point, density, mass, volume. Okay, basically if you can look at it and tell, or if you can measure it somehow using like a measurement device, then it's a physical property. Can y'all give me some other examples of physical properties? Sure, if it has a smell. Sure. Texture, how it feels. Freezing point. Same thing as the melting point. How about the amount of energy it has? Kinetic energy it has. You could measure that. What about the weight of it? You can measure that. Temperature. How reflective it is. Is it shiny? Is it dull? Sure. Is it elastic? Is it stretchy? Is it what the state of matter? Is it a solid, liquid, or gas? Does it conduct electricity? Does it conduct heat? I mean, there's lots of physical properties. Make sense?
Yes.
Okay. And the reason it's important to know physical properties is we can use physical properties of elements to separate mixtures. Okay. Oh, there's one more physical property that's important. Magnetism. Okay, magnetism is a physical property. If something's attracted to a magnet, I mean, you stick a magnet up to it, and if it attracts, then it's magnetic, and if it doesn't, then it's not, right? So, what we're going to be talking about today is physical separation techniques. And what I mean by physical separation techniques is ways that we can take mixtures and using the physical properties of the things in the mixture separate them. Okay. Can you separate compounds using physical properties? No, okay? Because the compounds are bonded together. Okay, mixtures are not bonded together, so you can separate them. But compounds you cannot separate using physical properties. Okay, so let's go through some of these if I can find the thingamabob. All right, so the first separation technique I wanted to go through is called magnetic separation. Let's say I have a container, and the container is full of iron particles and sand particles, and they're mixed in. So we'll call these the sand particles. Now let's say that's just the particles. They're all mixed in there. That's some iron particles and sand particles mixed together. What kind of mixture would that be? Probably heterogeneous. I mean, you'd be able to look at it and see, there's some sand particles, there's some iron particles, right? Okay. Let's say I took a magnet. Doesn't matter what end of the magnet. And I put this end of the magnet over here. Maybe a north end. It doesn't really matter. Well, the sand particles move toward the magnet. No, because sand is not magnetic. But the iron particles would, right? So what we would see is the sand would stay over there, but the iron particles would stick to the magnet. Do you see how that separates that mixture of sand and iron? Okay, here's an image of that. No. Well, I'll get to it. I don't know why I did that. Okay. So if I had some sand and some iron particles mixed up, iron particles would be drawn to the magnet, sand wouldn't. Okay, that's using a physical property to separate a mixture. Okay, so let's define magnetic separation. Magnetic separation is using a magnet to separate a magnetic and non-magnetic material. Okay, can y'all think of some cases where magnetic separation would not work?
If they were neither none of the mixed particles are magnetic.
Sure, if neither of the mixed particles are magnetic, then the magnetic separation is not going to do anything because they're not going to be drawn to the magnet. What else? If they're both magnetic, right? I mean, if this was some iron mixed with some steel, well, theirs are both going to be drawn to the magnet, and so that wouldn't work either. Okay? So I have to have one magnetic thing, one non-magnetic thing. Okay? Other thing, just kind of a real life example tip. If you're going to use magnetic separation, that doesn't need to be wet. Okay? Because if the iron is stuck to the sand, then you'll just get a clump of sand and iron stuck to your magnet. So they need to be dry so they can kind of sift through each other. Okay? Because this would just be like a clump of magnetic stuff. It's not gonna separate. Okay, the next method is called filtration. You have some spaghetti. You're boiling the spaghetti. Okay, the spaghetti's done. You know, as the spaghetti's sitting in there with water, that'd be a heterogeneous mixture, right? I see spaghetti, I see water, they're mixed up, and I can tell which one's which, right? Okay. What do you do right after you're done boiling the spaghetti?
You put it inside the meat.
But right before that,
You
drain it, right? You drain it. Okay, so you pour the spaghetti into something. The water's allowed to drain through, but the spaghetti doesn't. Right? Okay, that's separation by filtration. Okay, so separation by filtration is using a filter to separate particles by size. Okay, so the spaghetti's big particles, water's small particles, so it gets through. Makes sense? You do the exact same thing with sand. Let's say I have some sand and rocks mixed up. I want to get the sand and rocks separated. I pour the sand into a filter. It's going to go right through, and the rocks aren't. Okay, that'd be using filtration to separate. Okay, we use the exact same thing with dirty water. Okay, if I have some dirt and some water, then I would have, let's say over here I have a filter, has real small holes in it. And I'm going to put some water at it. And let's say that water is dirty, and so it has some some contaminants in it. Well, maybe some bacteria, maybe some dirt. Okay, that dirt, just like the spaghetti, comes and hits the filter. It's too big to go through, and so it gets stuck to the filter, and so the clean water comes through, but the particles don't. Can a filter get anything out of water? Do you have perfectly pure water on the other side of the filter? No. Okay. There are some things that are too small and they can go right on through that filter. Okay. Can we filter out bacteria?
Yeah.
Some of the time. Okay. That's the reason why if you go into a hospital sometimes, if there's like a really bad infection, you'll see people wearing masks. Okay. Air's filtering right through that mask, but bacteria, okay. Not a perfect system, but it works. Why do we use nitrogen in car tires now? They started filling up car tires with nitrogen now. What happens to your car tires over time if you just leave them there? They start to get flat, right? Okay. How do you think they're getting flat? Some of the air's leaving, right? Okay. If the air's leaving, that means it's small enough to get through the tire. Well, nitrogen is just bigger. Okay. Nitrogen is a bigger particle, so it doesn't get through the tire. It's more expensive than air, but it's not. I mean, it's not expensive to fill your tire up with nitrogen. Okay, so magnetic separation, using a magnet to filter, filtration, using different particle size to filter, and the last one we're going to use is distillation. A second ago, we said that a filter won't catch anything. If I take some salt water and I put it through the filter, what do I have on the other side of the filter? Salt water. Okay? You can't filter salt out of water. Okay? So we got to figure out something else to get salt out or to get something else out. Okay? And that's going to be distillation. Okay, so what we do in distillation, let's say I have a pot of salt water, and it's filled up to a certain level. I'm going to take a flame, I'm going to put it under that pot. That's a really bad drawing of a flame. We'll put two under there. This is getting embarrassing. Okay, we take a flame and put it under that pot, and the water's going to start to heat up, right? Eventually the water's going to get to the boiling point. What's going to happen? It's going to boil. It's going to evaporate. Okay, so that water's going to evaporate. It's going to leave, and so slowly that water level's going to come down. Do you think salt boils at the same temperature as water? No, salt boils at a much higher temperature than water. So when the water's boiling, what's happening to the salt? It's just sitting there. Okay? So once all that water is gone, all I'm left with is salt. Okay, and so I've separated salt from water. That's distillation. What do you think I need to do if I want to keep the clean water instead of the salt? Yeah, okay, so in that case I want to capture the steam, and then I have salt water, and then I have fresh water. Okay, so I would put something cold up here, and that steam would gather on here, and then the water would drip down, and we'd catch in another container over here, and then I have fresh water. Okay, so distillation, if I'm giving that a definition, using multiple boiling points to separate mixtures. Typically, we're talking water. Okay, if you take some Coke and you boil it, what are you going to be left with? Sugar, salt, syrup, contaminants, minerals. I don't know how many minerals there are in Coke. Okay. I've heard that, but I don't know if that's true or not. Kind of hard for me to say. Yeah, it's. Well, they knew that it was addictive, and so they put it in there just to make Coke addictive. At least that's what I've heard. I don't know if it's true or not. Okay, so let's say I want to separate quarters from dimes. What do I use?
The first one of those little
It's filtration, isn't it? Quarters are a different size than dimes. Okay, so that would be filtration. Let's say I want to separate alcohol from water. Distillation. Okay, and that's how they make really high concentration alcohols. Is distillation. Y'all heard of that before? A distillery. That's where they make alcohol. Okay, that's the process of distillation. And then magnetic separation. Really, the best example to me is separating out iron filings. Any questions?